Okay, let's start with supervised learning. Now suppose I have some historic data about some health trial participants, and I've got the exercise they've taken, the number of calories they've expended, and so on. And I might want to explore how I could use machine learning to predict how many calories a new participant might be expected to burn while engaging in some exercise. When we need to predict a numeric value, like an amount of money or a temperature or the number of calories, then what we use is a supervised learning technique called regression. For example, let's suppose Rosie here is a participant in our health study. Here she is taking some exercise. Now we gathered some data about Rosie when she first signed up for the study, and while she's exercising we'll capture more data using a fitness monitor. Now what we want to do is model the calories burned using the features we have for Rosie's exercise, her age, weight, heart rate, duration, and so on. And in this case, we know all of the features and we know the label value of 231 calories. So we need our algorithm to learn a function that operates on all of Rosie's exercise features to give us a result of 231. Now of course a sample of only one person isn't likely to give us a function that generalizes well. So what we do is gather the same sort of data from lots of diverse participants and train our model based on this larger set of data. After we've trained the model and we have a generalized function that can be used to calculate our label y, we can then plot the values of y calculated for specific features of x values on a chart like this. And of course we can interpolate any new values of x to predict an unknown y. Now because we started with data that includes the label we're trying to predict, we can train the model using only some of the data and withhold the rest of the data for evaluating model performance. And then we can use the model to predict f of x for the evaluation data and compare the predictions or scored labels to the actual labels that we know to be true. The difference between the predicted and actual labels are what we call the residuals, and they can tell us something about the level of error in the model. Now there are a few ways we can measure the error in the model, and these include root mean squared error, or RMSE, and mean absolute error. Now both of these are absolute measures of error in the model. For example, an RMSE value of 5 would mean that the standard deviation of error from our test data is 5 calories. Of course, absolute values can vary wildly depending on what you're predicting. So an error of 5 calories would seem to indicate a reasonably good model, but if we were predicting how long an exercise session takes, an error of 5 hours would indicate a really bad model. So you might want to evaluate the model using relative metrics that indicate a more general level of error as a relative value between 0 and 1. Relative absolute error and relative squared error produce a metric where the closer to 0 the error, the better the model. And the coefficient of determination, which we sometimes call R squared, is another relative metric, but this time a value closer to 1 indicates a good fit for the model.